Java compiles to bytecode, and bytecode decompiles back to source almost perfectly. The usual answer to that has been obfuscation. But does obfuscation still hold up now that we have AI? First, here is the code we want to protect. An order pricing system. 6 classes. It discounts by customer tier. Enterprise accounts get 18% off. Then, it hashes the order details into a risk score and uses that to nudge the final price. Finally, it builds a digest for auditing. Run it once, and remember these 3 numbers. We will compare against them later. Now we put it through a commercial obfuscator with every option turned all the way up. Class and method names become single letters. Strings get encrypted, control flow gets scrambled, debug information is stripped. That is about as far as obfuscation goes. Decompile it, and this is what comes out. Classes called C, B, and E. Fields called F2A, B, C, and D. Nothing tells you anything. The strings are gone too. All that is left is a pile of hash code numbers. The control flow is padded with tests that are always false, plus a safety lock that never fires. Even the decompiler struggled. JDEX truncated one of the constants right here. Now we open a completely fresh AI session. No original source, no hints, just the decompiled mess pasted in. It did 3 things. First, it decrypted the strings. Gold, enterprise, and silver all came back. Then it worked out that those tests are always false and cut the unreachable branches away. And finally, it followed the data flow and inferred what every class and every field is for. This is the code the AI recovered. It picked the names itself. The logic is identical. Compile it, run it, and those 3 numbers match the original exactly. Let us check it, item by item. 5 of the 10 names match the originals exactly. The other 5 are synonyms. It called order item and risk engine hash engine. But the names were never the point. The pricing formula, the discount tiers, the hash, the digest, all of it lines up. So why doesn't obfuscation stop AI? Names don't matter to it. It reads how the data flows and what calls what. Fake branches have fixed outcomes. Once it spots one, the whole block goes. And the decryption logic has to stay in the bytecode, or the program itself couldn't run. On top of that, the AI has seen these patterns countless times in training. What about encryption? Better than obfuscation, but ordinary encryption isn't enough either. Decrypt in a custom class loader, and the result still has to be handed to the virtual machine. Attach an agent, and you capture the class at that exact moment. Move the decryption inside the virtual machine, and the agent is blocked, but the plaintext bytecode is still sitting in memory. Dump the process, and you can analyze it anyway. If the plaintext ever exists, it can be taken. So the real line isn't obfuscation versus encryption. It is whether the plaintext ever exists at all. To stop AI, the plaintext must never appear, not once, anywhere.